So this time I wanted to bring you a small Arduino project. So I've got an Arduino board here, more of that in a minute. And what I want to do is build something like this. And you might have seen things like this before. So this is basically like a tiny keyboard that you can plug into the USB. So you have 3 programmable buttons that can send different sequences. And then this one, it's also got a volume control on it. And it's got a display, although the display doesn't seem terribly useful. So I want to build something like that myself using this Arduino. And the purpose really is to have a controller that I can use to control Zoom sessions. So there are things that you can switch on and off during a Zoom session with a button. So for example, you can switch cameras, you can switch the video on and off, and you can mute and unmute yourself. And I'd like to make my own remote Zoom controller. So I've got this. I also bought this remote control. It's some kind of infrared remote control, but the important thing for me really is that we've got some buttons in here. I'm thinking of using 6 buttons, and I'll cut tracks and remove the electronics because I don't really want the electronics, I just really need the buttons. And then if I need to, I'll cut the bottom off the board to make room for the Arduino inside here. So I should end up with a handheld controller that I can plug into the USB, which will then allow me to control my my Zoom sessions. And also, if Zoom isn't your thing, I can show how to program other button sequences in. So if you're using Teams or some other thing, then you'll be able to use the same project. So as for this, I mean, this is obviously much smaller than the standard Arduino, so like it's much smaller than the Arduino Uno, and it has a more modern interface on it. So it's got the USB-C interface. This one is actually called the Pro Micro, but in terms of technology on board, it really looks much more like the Leonardo. So the Leonardo has a different controller, which is what I'm interested in here. So the controller on here is something called the Atmega 32U4. So that's the same processor as on the Leonardo, and a unique and different thing about that is that the USB controller is actually on the microcontroller rather than being a separate chip as it is with some of the sort of low-end Arduino boards. And the reason that's useful is because then you can actually reprogram the USB interface rather than the because with the standard Arduino it can only ever be a COM port. So conventionally we use the COM port to load software into the Arduino, and then once it's running we can actually repurpose the serial port as well, so we can use it to drive other things like GSM modules, for example. But the 32U4 is more interesting than that because we can actually reprogram the controller, and we can say that it's a keyboard or a mouse, so an HID type device in the sort of PC nomenclature. So that means that we can tell the computer that this is a keyboard. So when we plug a USB cable in here, the computer will actually recognize this as a keyboard, and so it will be expecting button presses and button releases. And we've got a couple of interesting Arduino libraries that we can use to make it very easy to use those kind of things. Now, so the first step normally with an Arduino is we make sure that we know how to program it using the IDE. So we need to load up the Arduino IDE and typically the first thing you do is you load the script called blink. So there's a blink script that allows you to just kind of make sure that the board is working and flash an LED on the board. So that will be our starting point today. I'll download the blink sketch, as it's called. Right, a small setback straight away. So I've found the correct setting, so the correct board type to use. So I've chosen Arduino Micro, and if I do upload with the blink sketch, you can see, so it's compiling. And now it's uploading to the board. You can see the red lights are flashing, but there's no blinking. So there are two red LEDs on here instead of the usual one green LED. But the blink script doesn't actually work, so I'm going to have to find out what's different about this board. Okay, so what I've discovered is this board has got the two LEDs. It's got a transmit and a receive LED, but they're on different pins to the standard Arduino. So, as it says here in the comment, the blink script is looking for pin 13, which is the one that's connected to an LED on the, for example, on the Arduino Uno. But in this case, the two LEDs are on different pins, so I'm going to have to reprogram this a bit. So you see in the script it's using this LED built in, which is a synonym for pin 13, and then we've got this loop where it sets the LED on, waits 1000 milliseconds, and then sets it off again. So we have to find the correct pins for the Leonardo and therefore for the Arduino Pro Micro. Okay, so similar test now. So I've modified the blink script. So now we've got receive LED is pin 17. So I've set it for pin 17. So I'm setting up that pin 17, and it's quite similar to the old script. The variable's got a different name, but other than that the function is the same. So I'm setting the LED on, waiting half a second, and then setting it off again. So let's try that. There we go. So now we have a flashing LED. Actually, in the IDE, it's got this rather alarming red text down the bottom, but it does seem to be working. I mean, it is loading the software onto the Arduino, so that's good, I think, even though it looks like it might have broken. And I was reading that you can also flash the transmit LED, although for some reason you can't use this similar structure. You can't use the digital write, but instead there's a pre-set up macro that we can use. So I'll try and put that in. TX LED 1, I think that's what I read. TX LED 0. Let's try that. Sorry, for some reason the camera went off just at exactly the wrong time, so let me do that again. I tell you what, to make it obvious that it's actually changed, if I change these back to 1000 milliseconds, and then we should get a longer flash duration on the LEDs. Oh, there's the reprogram. There we go. So now it's set to 1 second. So that's good. So we've discovered what type of board we need to set it up for the IDE, and we've successfully run the blink script. So I can feel confident now that I can start writing code to do the job that I want it to do, which is to read the input pins and to send different sequences of characters based on it. So basically what I want to do, because there are a whole load of digital pins here, so I can connect 6 of those buttons that I've got on my printed circuit board. I can connect 6 buttons, and then I'll have 6 different inputs that I can detect with my program, and I can send different sequences depending on which button has been pressed. So let me start looking at that. Alright, so this is what I've come up with. So I've called this button press. I just want to do a simple test really. So I'm going to look at pin 2, I think. Yeah, that's, well, so it's button 1 because it's the first button that I'm looking at, but I'm actually going to use the digital pin number 2. So I've got the 2 set up here. So I'm using this library easy button, which allows me to define a button and attach it to a particular pin. I'm also using this thing called internal pullup, which I'll describe in a minute, but it allows me to save some components actually when I build this, when I attach the buttons. So we'll look at that in a minute. So I'm going to set the debounce delay, and debouncing is because buttons are not perfect. They can actually flicker on and off a bit when you press the button, and computers run fast enough that they can get confused by the different transitions, so you need to do debouncing. So that's what I'm doing there. So we've got 50 milliseconds of debounce time to make sure that we're reading that the button is on or the button is off. So in the main loop, this is the way that you use easy button. You call this thing called loop, and then you can detect whether the button is down or the button is up, and we should be able to see these in the serial interface. So let me just program that. What's happened? Can't see the board now. COM8. Here we go. Try again. Okay, so that's programming now. And now, as you see on the board, the lights have gone off, so it's running a different program. But I should now, if I can short the button 2 together with ground, we should be able to see that it's doing something. So if I just start the serial monitor, okay, look at the output. No, serial monitor, that's right. So if I can short these buttons out, these pins, no, that doesn't work. Let me see if I've got a bit of wire. Let's try and use this pair of scissors to short out those 2 pins. So one is the ground, and then the pin 2 is directly next to it. So let's see. There we go. So that works. So you see, so when I short the pins out, we get that message button 1 is pressed, and when I take the scissors off again, we get the button 1 is released. So basically it's reading that pin and calling the code that I've written. So the next thing is then to actually make it do what I want it to do. So I'm already including this include keyboard.h. Keyboard.h is the one that does the magic in terms of presenting keystrokes to the PC. So it allows me to pretend that, for example, Control J has been pressed on a keyboard. So let me make some further changes. I'll add some more buttons. So we've not just got the B1 button, but we've got 6 buttons. And then we can start to program them with the right values that we want for zoom. I was just looking at this board from the little handheld remote controller. So remember here I was only going to use the buttons. I'm not interested in any of the electronics. So I was just kind of buzzing it out with the multimeter here. And what I've spotted is that this outside line of pins to the buttons and this outside one here, they're all interconnected. So this will be the ground side, I imagine. So if I can basically tell that all of these are interconnected, and then the switch itself actually goes in this direction. So if I put my buzzer on the 2 pins here, when I press the button it shorts it out. So basically what I think I need to do is just connect one of these outside pins to ground, and then these 6 are going to be my functional buttons. So I need to put 1 wire to each of those 6 inside terminals, and then that's probably all I need. And I don't really need to do anything in terms of taking anything off the board. And when I'm looking at here, there's obviously some transistors, an infrared LED, a regulator, I think, and whatever magic makes this infrared remote control work is in this chip. But I'm not really interested in any of these bits of electronics, so I probably won't even bother to take them off. So this is what I've come up with. So now we've got a number of different buttons, 6 buttons instead of the single one. And so I have to set the debounce time for each of those buttons. We have 6 loops here. And then each individual button has its own action. So for example, button 1, when I get the is pressed event, what I'm doing now is I'm going to use that keyboard library and that's going to hold down Alt and press A, and I'm doing that because that's the zoom shortcut key code for mute. So Alt A will mute and unmute, and similarly button 2 we've got Alt V, which is the zoom code for video on, video off. So you can go in and you can fill in whatever actions you want in here. So Alt N in zoom switches between cameras if you've got multiple cameras, and Alt Q will exit out of the program. I've added 2 more on here as well, button 5 and button 6. I'm not sure what I'm going to use those for in actual reality, but I put Control C and Control V, which are used for cut and paste, so that should make it easier for me to actually test this in a minute. So I said earlier I was going to explain some of these things. So for example, the pull-up. So if I draw a little circuit diagram, so this is a resistor and a switch. And this is going into the input of an Arduino. So let's say this is pin 2. So imagine this is button 1 and we're going into pin 2. So this is what's known as a pull-up. So connecting to the power rail to 5 volts through a resistor, what that will mean is when the switch is open, this pin 2 is pulled up to the rail. So pin 2 will be at plus 5 volts when the button is not pressed, and then when I close this button, this will basically short circuit this, and this is a more current can go to ground through here than would be able to through the resistor. So then pin 2 is pulled to ground, and so this is known as a pull-up resistor, and this is the pull-up implementation of a switch. Now if I did it this way, I'd have to supply a resistor for all 6 switches, but luckily for me in Arduino you can actually get rid of this. So if I set that input pull-up in the Arduino, then this actually gets implemented inside the chip, so I don't need to build this. It somehow magically happens inside the Arduino here. So that's what I'm doing here. I'm saving myself 6 resistors and a bit of fiddling about by using the internal pull-up. Also, let's talk about the debounce delay. So debouncing is something that you do to switches when you connect them to a computer, because if you looked with an oscilloscope, when a switch closes, so let's say the switch is at 0 volts because it's not connected, and then I flick the switch and it's going to go up to 5 volts, which is this level here, then what actually happens, because switches are mechanical and there's a little bit of copper in there that can bounce around, is the signal can thrash around here for a while before it decides that it's actually at this high level here. And so what I can do, so the problem is that the computer can read the switch very rapidly and it can get confused by these different transitions. But what I can do is set a debounce timer, which means that if I set the timer here, say for this 50 milliseconds that I've specified in the program, then basically while this is bouncing around I'm not paying any attention to what the value is, but as soon as we get to the 50 milliseconds, here's where I will actually take my sample, and then I'll be able to reliably read that this is now at 5 volts. So this software debouncing is quite useful for, you know, sort of overcoming the realities of physics. So that should be about all I need to do in terms of software. So we can have a look at wiring it up so that the button, the wires are going to these pins 2, 3, 4, 5, 6, 7. So these were just all the pins along one side of the Arduino, so they were convenient for me to put wires onto. And you see in this case they're just kind of one off the button number, but it really doesn't matter, it's quite arbitrary. So let's have a look at how I've wired the Arduino. So I managed to find some coloured wires, and as you see I've put each coloured wire on the inside pin of these first 6 buttons, and then there's a black wire here which is my ground wire, and that's going to the outside pins. Actually this outside rail here is connected to all the switches. That's my ground rail, and then inside the circuit board it's actually already connected to this side of the switches, so that's quite convenient for me. So you'll see I took a couple of buttons off here to make a bit more space. I thought I was going to put the Arduino on top, but actually the way it fits into the case, it's better to kind of have it underneath. So I put that underneath. I put some tape on here to make sure it doesn't short out anything on the end of the Arduino here. I also took out, there were a whole load of transistors in here, and I took those out because I didn't want to take the risk of things shorting out. So, like one button might affect another because the current is running through a transistor. So I just took them off. It only took a couple of minutes to desolder the components. So that should be it. And if I plug this in now, so we'll put this in here, so the Arduino has come up. You can see the RX TX lights are lit up, and if we have a look inside my zoom control program, we should be able to see when buttons are being pressed. What do I want? Serial monitor. There we go. Let's switch on the serial monitor. Alright, okay, so we've got the serial monitor down the bottom here. So that would seem to be connected. So if I press button number 1, it should be that left hand one. So you get button 1 is pressed, button 1 released, there's button 2, button 3, button 4, button 5, and button 6. Oh, 6? Yeah, 6 is working. It just didn't scroll there for a second. Let's have a look at that. Press button 6. Yeah. So I've got all the buttons working. So now the thing to do is to actually check whether it's really doing anything. Which is where the cut and paste comes in, my Control C, Control V. So let's just pop up Notepad, I suppose. Okay, so if I put something in Notepad, for example, and then I can highlight the text, and if I hit button 5, which should be Control C, that should copy the text. And then let's move somewhere else. And if I hit button 6, that's Control V. So you can see whenever I press that button, it'll now paste that text that I put in. So that's a good sign. That means that these buttons are actually being picked up by applications inside the PC. So the next thing will be to actually fire up Zoom and see if any of these shortcuts work in Zoom. Okay, so here we are in Zoom. I don't actually have a camera attached to this PC, which is why you can't see a picture, but you know, we've got the normal operating buttons here, so you can see that start stop video is Alt V, mute unmute is Alt A, and I should be able to do that with the keys here. So button 1 is audio, so there we go. So I managed to mute with the button 1 like so, and button 2 is video, so if I press that one, it switches out to my still picture, and Alt V switches the video on and off. What was the other one? I could also do quit, couldn't I? Is that 4? Yeah, so then the pop-up happens for the end meeting. So there we go. I can control Zoom with my remote control. So the next challenge is to try and squeeze this into the box here and make sure that everything fits. Well, I can't quite get the case to clip shut, but you can see basically the result. I mean, the Arduino is stuck out a little bit here as well. I might have to do a bit more work at this end, but we've got the buttons still accessible, and I just need to make a few more cuts at this end, I think, to make room for the Arduino. Perhaps cut away this red section from the top of the case here so that I can actually snap it shut. Right, so it's not quite as good as I wanted it to be. It's there's a little bit of a gap there, and the Arduino sticking out a bit at the bottom, but basically this is now working. So if I press the 1 button, we can see it come up on the Arduino serial output display. Button 2, button 3, 4, 5 and 6. So there we go. I've got my handheld remote controller for controlling Zoom meetings. So my Arduino sketch, my software, I'll put up on the GitHub site. On my GitHub site, the link will be down below. If you want to download the software, use it yourself and experiment with it, you'll be able to do that. So thanks for watching. See you in the next video.